Okay, so we're going to move ahead with patterns, and there's another example that I want to give you regarding linear sequences. And this one is where we're starting with the description and we're asked to write down the numerical pattern ourselves. So a sequence is described as linear, starting at 20, adding 6 every term. Write down the first 5 terms of this sequence. So pause the video to take that down into your notes copies, and then we'll go through the solution. Okay, so this sequence, we're told it starts at 20, which means the first thing I write down is 20. It's linear, which means it's got the same change, the common difference every time, and I'm told that what I need to do is add 6. So when I add 6 to 20, I get 26. And then because it's linear, that's the same thing I do every time. So 26 plus 6 is 32. I don't need to do this every time. 32 plus 6 is 38. And 38 plus 6 is 44. 1, 2, 3, 4, 5. I've written down the first 5 terms there successfully. If you want, you can keep putting in the common difference there every time. Okay, so that's linear sequences. Now, I want to introduce a new type of sequence, which is non-linear, and that is a quadratic sequence. So quadratic sequences, we'll be doing quite a lot of work with these in our lives. So pay attention to this word. You're going to see it a lot over the course of your mathematical career. The first thing we want to say about them is that they are not linear. So the first difference is not constant. What is constant is the second difference. So the second difference, what does that mean? Well, I'm going to show you with an example now in a second. The second difference is constant. So of course, quadratic sequences need to be numerical as well. All of these types of sequences that we're going to learn in the next while have to be numerical sequences because we need to be able to do addition and subtraction and multiplication with them. So, investigate if the following sequence is quadratic. Write a sentence describing the sequence. So here we go. Here's the sequence. It starts at 2. Nine, 17, 28. Okay, so we're to investigate if this sequence is quadratic. Well, the first thing we're going to do is we're going to check the difference between the terms. So to go from 2 to 4, I added 2. To go from 4 to 9, I added 5. To go from 5 to 17, or 9 to 17, I added 8. And to go from 17 to 28, I added 11. So we can clearly see this is not linear because the first difference is not constant. This is not a linear pattern. What am I talking about when I'm looking for the second difference? So this line here is what we call the first difference. And the existence of the first difference implies the existence of the second difference. The second difference is when I look at this list of differences here and I check how they are changing. So to go from 2 to 5, I added 3. To go from 5 to 8, I added 3. To go from 8 to 11, I added 3. So we can see that my second difference is constant, which means this is a quadratic pattern. So it is a quadratic pattern, quadratic sequence. because the second difference is constant. It's the same every time. It's not changing. So, have I answered this one? I have. And I've given my reason as well. Now, write a sentence describing the sequence. Remember, every time we write a sentence to describe a sequence, we need three things. We need the type. So this is a quadratic sequence. We need the start. Always need to write down the start term. So the start term is 2, starting at 2. And then finally, we need the change. Now the change in this case is the second difference, not the first difference. Starting at 2 with a common second difference. And that's really important for quadratic sequences, that you'll say second difference, not first difference. So a common second difference of plus 3. So there's the description of my pattern, accurately described. There's one more thing we want to be able to do with these types of questions, and that is write down the next 3 terms in this sequence. So we'd gone 2, 4, 9, 17, 28, and I can't just add on 3 and I can't just add on 11. I have to figure out what I'm going to add on to the 28, and I do it by adding 3 to 11. So 28, my next one's going to be 11 plus 3 plus 14. And then I'm going to have to add on 3 to the 14, so plus 17. And then I'll have to add on 3 to the 17 plus 20. I'm just doing it up here so where I've got space. So you can see my second difference, the difference between the differences, is plus 3 every time. So 28 plus 14 is 42. 42 plus 17 is 59. 59 plus 20 is 79. So the answer down here, the next 3 terms in the sequence are 42, 59, and 79. So quadratic sequences are definitely a little bit more tricky to work with, because you have to work out that second difference and then use that to work out the change, your first difference at every step, and then you can work out the next few terms after that. Okay, so I'm going to stop there for today, and I want you to do a good bit of practice for the rest of your time in maths today. Thank you.